All right, continuing where we left off in that last video, our last shape that we want to talk about is a rhombus. And so we're still trying to figure out how triangles can help us find perimeter and area of parallelograms and rhombi. So here's the rhombus. A rhombus has two diagonals. A rhombus also bisects both diagonals. So it cuts each diagonal into equal halves, although each diagonal is not equal in a rhombus. There's an area formula that says that if we multiply our two diagonal lengths together and then divide by 2 or cut that in half, we get the area of the rhombus. It's kind of a crazy formula, and I'm going to break it down and show you why that's actually true, and it has to do with triangles. Before we do that, let's just talk about the perimeter real quick. The perimeter of a rhombus is 4 times its side length because each side length is exactly the same, just like in a square. Although you can always keep it simple and just add up all the side lengths if you wish. So why is this area formula possible? Well, let's look at the rhombus. There's actually 4 congruent right triangles. So one thing we could do is find the area of one of those triangles and multiply it by 4. But there's also 2 bigger congruent triangles. Each half of the rhombus is a bigger triangle. And that's actually where this formula comes from. So if we just take half of that rhombus and just look at it, the base of this triangle is actually one of the full diagonals, and the height of that triangle is actually half of the other diagonal. We'll come back to that in a second. Let's remember that the area of a triangle is base times height divided by 2. Well, if we have 2 of those in a rhombus, I could multiply that formula by 2. Well, if I'm multiplying or doubling this formula by 2 and dividing by 2, those cancel. So the area of a rhombus is really just base times height of its triangle, the bigger triangle here. Well, the base of that triangle is a full diagonal of the rhombus, and the height of the triangle is a half of a diagonal of the rhombus. So then the area of a rhombus must be a diagonal, full diagonal, times a half diagonal. So you can always break a rhombus down into triangles if you ever forget these formulas. Let's practice finding the perimeter and area. In the example on the left, we're given halves of the diagonals. So let's finish off the diagonals. If half here is 6, the other half here must be 6, making this full diagonal 12. If this half diagonal is 4, the other half must also be 4, making the full diagonal 8. So since we have our full diagonal lengths, we can plug them into our formula and find the area. Multiply the diagonal lengths together and divide by 2. And there's a lot of ways to do that computation and get the area of 48. To find the side length, though, let's look at this right triangle right here. Because in a rhombus, these diagonals are perpendicular, we have 4 right triangles, and let's just look at one of them. In this right triangle, we know 2 of the legs, and we're missing the hypotenuse. Anytime that happens, we could use Pythagorean theorem to find our third side. And in doing so, we get either a radical length, 2 times the square root of 13, or we could use its decimal value, about 7.2. Now that we have the side length, there's 4 equal sides in a rhombus. We could just multiply that side length by 4 and get the radical perimeter or its decimal approximation. Over here on the right example, we're told the full diagonal lengths. So let's break those down. If the distance from A to C is 20 and we cut that length in half, each half must measure 10. If the distance from B to D is 15, then each of its halves must be 7.5 each. Since we're already given the full diagonal lengths, we could just multiply those 2 things together and divide by 2 to get the area. But to find the perimeter, we need that side length, which is the hypotenuse of one of these right triangles. And now we know 2 out of the 3 sides in that right triangle. We could again use Pythagorean theorem to find that hypotenuse, which is the side length of the rhombus. So the side length is 12.5. We could quadruple that, or add it to itself 4 times and get 50 as a perimeter. So there is how we can find area and perimeter of triangles, parallelograms, and rhombi. And a lot of times we are doing a lot of math with right triangles, because triangles are the building blocks of our other shapes.